Hey everyone, I'm Srushtika Neelakantam from the Developer Relations team at Ably. In this video, we'll see how to build a multiplayer version of the Flappy Bird game. By the end of this video, you'll have a game that looks and works like this, where you can have multiple people playing with you online, their avatars showing in sort of a parallax and translucent fashion, as in many popular games such as Bike Race. There'll also be a leaderboard that shows the live scores of everyone playing. This game is built in collaboration with two other YouTubers, Anya, who does amazing JS game walkthroughs on her channel, and Eddie, who builds really useful web dev tutorials and shares tips and tricks on open source and programming in general. If you've come here from Anya's video, then you're in the right place. For those of you who've landed on this video directly, this is part 2 of a 3-part series. The first video is on Anya's channel, where she shows how to build a single-player Flappy Bird game in vanilla JavaScript. I'd recommend you checking it out using the link below, as we'll start off with that project as a base and make it multiplayer in this video. Part 3 would be a QA session on Eddie's channel, also linked in the description, where the three of us delve deeper into various concepts and technologies involved in this project. So let's get started. Just to recap the part 1 video, it looks like this. In order to make it multiplayer, we'll need a leaderboard and a field to capture the player's nickname so they can be identified on that leaderboard. What I've done is made some changes to that base project to add the nickname and the score fields, as you can see, and made that as a pre-release on my GitHub. So I'm mentioning the link to this in the description. You can just go to that and click on source code zip file, download the zip file to get all the base files to start off the project. So the game from this pre-release looks like this now, where you can see the score label updating as the bird is crossing these different obstacles. Here's the code base from that release that I just showed. Let's begin by going through this app.js file to see what we already have and what we're working with. So I have a profanity base URL variable. Essentially, when you type the nickname in the field, if there are some bad words, we'll mask it using this free profanity filter, which will replace any bad words with 3 stars. I'll show you that in just a second. Then there's nicknames dictionary. This is just a list of random bird names with random colors. We'll use this to assign a nickname initially to a user whenever they join. Then we have a bunch of other variables that we'll see later. There's also a high score nickname, and that is just, anonymous panda for now. We'll implement it later. So this is interesting. I'm using local storage to actually store the nickname, saved by the user using the button. Why this is being done is because Flappy Bird is a game that you keep on playing again and again. Every time you press refresh, the nickname that you saved goes away. Instead, if we saved it in cookies, you just, retrieve that back and you don't have to change that all the time. So if it's there, you get that from the local storage. Otherwise, just randomly assign something and save that in the local storage. All right, so let's maximize this method, which is called as a callback when the JavaScript or like the DOM has actually loaded. Inside this, we have reference to a bunch of HTML elements for all the elements that we right now have. These are initial values for some of the game elements that we have. So that's where they start off from. And this is the method, the filter nickname method, which is actually called to filter the nickname that, people write. So this is being called from here whenever the update nickname button is called. The filter nickname is called with that value. And inside that, we're just making a request to the profanity filter and telling that to replace whatever bad word is included, if at all, with the 3 stars string. And that will do that and give us that in the response text. And when we get that, we're basically saving that as the nickname and then updating the local storage and the value of the nickname input as well. Initially, we're just keeping the score as 0, anonymous panda, as you saw above. Okay. And then we have a event listener for key down. Basically, this is preventing the default behavior when the space bar or any other key is pressed. Why I'm doing this is because generally on web pages, if you click on spacebar, it scrolls the page down, and we don't want that happening if, this game is being played in smaller screens. So right now, as you saw, the game doesn't really start directly as soon as you load the page. It waits for you to click on the game area. So this is what that is doing. It basically looks for the onClick method to be triggered on the game display area or the element. And if that happens, it'll check if the game has already not started, because you don't want multiple clicks to start multiple games. And it will register an event listener then, which is key down. And every time that happens, it will call the control method. In control method, it is checking if that is the spacebar, the key that was pressed using the key code, and it will implement the jump method. In jump method, we'll just check if the bottom position of the bird is less than 500, just to make sure making the bird jump from there doesn't make it go over the ceiling. If that's not the case, then we'll just increment the position of the bird by 50 pixels. And that's what's happening here. So going back to the game display on click. That's what was happening with the control. Next is game timer ID. We basically set an interval and call the method start game every 20 milliseconds. So what's happening in the start game method is that the bird's bottom position is being reduced by the amount of gravity, which is here too at the moment. So that's what's happening, basically making the bird fall continuously towards the ground. So that's the start game method. And if we go back here, there's another method called generate obstacles. What happens here is it generates the obstacles, the pipes that you see on the top and the bottom. It does so if the game is not yet over. And essentially, the way this works is it starts off an obstacle from the right and moves it towards the left of the screen. And if it has left the screen, it will remove it from the HTML. So it'll do that, randomly assign the height, and append the obstacles to the game display. And we also have the move obstacle method within this method, which is used to move the obstacle. And this is being called every 20 milliseconds again to, sort of make it look like a video in a smooth motion. Inside this move obstacle, we're just reducing the left position of the obstacle by 2 at very high frequency. And if this obstacle reaches 220, which means, it has reached like half the area approximately where the bird is. It means we can count as the bird having crossed that obstacle. So we can increase the score by 1 and update the score label with that updated score. And we'll check if the obstacle left position is minus 50, which means it has gone out of the game display towards the left. So that is when we need to remove it from the HTML using remove child. And this is basically, this if condition is checking a bunch of conditions to see if the bird has touched any of the obstacles or the ground. If so, that's game over. So that method would be called, and any of the timers that were started to move the obstacles, they all will be cleared. And the is game over variable will be set to true. And this whole generate obstacles method is called once when the game starts, and then every 3 seconds from within this method. So it keeps generating obstacles every 3 seconds. Right, so in the game over method, when it is called, it will start off with setting the text of the score label, basically appending it with the text game over, just so the player knows that, okay, it's done. Other than that, it will also remove a bunch of listeners and also make the ground stop moving by updating some CSS elements. Sweet, so that's all we have in the app.js right now. Let's quickly run through the things we'll cover in this video. Because we're making this game multiplayer, we need to set up some sort of a communication between all of these different players that are playing together. So we'll start off with understanding the networking strategies for these players to communicate with each other, which is more efficient and which is not, and why. We'll implement a strategy called the client-server strategy, which you'll know from the first part of this, to actually make the game multiplayer, and then we'll make the players and the game server communicate in real time over WebSockets using Ably. Now, don't worry if you have no idea what any of these terms mean, because that's what you're about to learn. Sweet. So let's start with the networking strategies. Now, for any game to be multiplayer on the network, there needs to be some sort of a way in which all these players are able to communicate with each other. So naturally, the easiest strategy to think and implement is the peer-to-peer or P2P strategy, where every player is connected to every other player, as you can see here. While a lot of multiplayer games do work on this networking strategy or design, it's not that great. If you observe closely, the fact that every player is connected to every other player means a message published by player 1 will need to be sent to 4 other players, and the same thing repeats for all the players involved. So in a game with, say, n players, a minimum level of communication where all the players are actively participating is n times n, giving rise to an n squared time complexity. Poof, that's not great. Fortunately, there's another popular strategy that allows us to avoid this called the client server strategy. As you can imagine, all the players in this model publish their state to the server. The server, which we can also refer to as a game server in this case, syncs up the state received from all the players and publishes this collated state back to all the players. These two things, that is the data from the clients to the server and the data from the server back to the clients, are streamed continuously at high frequency, thus making it seem very smooth and nicely synchronized. Now, if you observe again, for a game with n players, there will be n publishers from each of the players to the server and n publishers from the server back to each of the clients. So n plus n gives rise to only big O of n, which is linear time complexity. This is much more efficient than the P2P strategy, especially in our game because it will involve high frequency data streaming, as you'll see soon. Right, now that we've decided we need a server, let's set that up. We'll write the server-side code in Node.js. For that, you'll need to have Node.js installed on your computer. You can easily download and install a suitable version from the original site. I already have it installed. Cool, so let's go into the project and make a few changes to the files and folders as we'll need the server component now. First, let's create a new folder called public and move all the client-side files into that. And then create a new file called server.js. We'll have the server play a dual role. A, to host our game files, and B, as a game server that can maintain the game state and publish it back to all the players. One thing we haven't spoken about until now is how exactly the players in the game server communicate with each other. We can send the basic REST requests over the HTTP protocol, but that's not really suitable for a live and high frequency communication that we're wanting to have. We'll need to use something more efficient like WebSockets, as it allows a persistent connection with duplex communication. Don't worry if all of these terms are super new to you. We'll not be working with these technologies directly in this app, but you can find out more about these under the hood concepts by following the links mentioned in the description. Building a WebSocket server from scratch is hard and tedious to maintain, as you can imagine. Even if you build one, there are many add-on features required on top of the basic WebSockets communication to make your app scalable and production ready. Fortunately, Ably offers various SDKs or libraries to provide just that, a WebSocket-based real-time messaging architecture that can fall back on other protocols if necessary, along with add-on features like reliability, unlimited scalability, authentication, and message ordering, to mention a few really useful features. So now Flappy Bird game will theoretically place Ably here. So all the messages from the players will go to Ably, and Ably will in turn send them to the game server and vice versa. All the participants are completely decoupled, and Ably takes care of all the messaging using its distributed network to ensure minimal latency for our high frequency communication. So that makes our work super easy. For this project, we'll use three libraries on the server side. The Express library, so our server can listen to requests and send back responses. We'll use this to send the game files to any player who'd like to play the game. The second one is the .env library to load any environment variables. And finally, the Ably library to implement WebSocket-based real-time messaging. If you're new to Node.js, just know that to use any external libraries, we'll need to install them using npm or the Node Package Manager. All the libraries used in a particular project are declared and shared using a special file called package.json. To create it initially, we can go to the integrated terminal and type the command npm init. It'll ask a bunch of options. We can leave them all default for now by just pressing enter. This will create a package.json file that has all the meta information about the project. Now we can go back to the terminal and install the libraries one by one using the command npm install --save and the name of the library. The --save option will basically list the library at that particular version as a dependency in our package.json file. Now anyone wanting to check out the project on their machine can easily get all the dependencies required by doing a simple npm install. We'll do the same for the other two libraries as well, npm install --save.env and then npm install --save ably. Let's go back to the package.json file to verify, and sweet. So all the libraries are now listed here. Now the last step is to get a reference to these libraries in our server.js file. We'll do that using the require keyword. So const env config equals require.env.config, because that's the method we need. Next is const express equals require express, and finally const ably equals require ably. We'll start with instantiating the express library, const app equals express, then app.use express.static. Here we'll specify the folder in which our files, which are supposed to be served, are, which is public here. And then we'll say app.get the home or the root URL, which is just a slash, request response, response.send file underscore directory name plus slash index.html. Basically, we're saying if I get a request to the root folder, I would like to send my index.html file back. We'll also add a listener, so this Express server can listen to requests on a particular port. So const listener, app.listen, process.env.port. We'll set that up in a bit. But in the callback, we'll just log that the app is listening on the port, which is belonging to the address of this listener that we set up. So listener.address.port. So this process.env.port is basically referring to an environment variable. Let's create a new file called .env and add a port number. Let's just say 5000. And this will be our process.env.port. And because we're using the library.env, we can easily reference to that. Okay, let's try running this server to see if everything's working as expected. So open the integrated terminal, say node server.js. This should start your server. Oops, there's a typo. I don't like typos, so just a missing space. Gotta stop the server, add the space, come back, run the server again. Sweet. In the browser, we can go to localhost 5000 port because that's what we set up. And okay, the game's running. Before we make any further changes to the server file, we need an API key to use the Ably service. So go ahead and navigate to ably.io and sign up for a free account. I already have an account, so I'm just gonna log into that. As soon as you sign up or log in, you will see a dashboard with all of your apps. Create a new app. Let's call this multiplayer Flappy Bird YouTube. Create the app and this will give us the API key. Don't copy this API key. I'm just going to deprecate it after the video. So just create a free account and you should be good to go. Okay, back in our code editor, let's save this as an environment variable. Ably API key equals paste that key. And in the server.js file, let's start with instantiating the Ably Realtime library. Const realtime equals new ably.realtime and we'll pass in the key as a parameter. This is process.env.ably API key, which we just saved. Now, even on the client side, we can do the same thing, use Ably API key to use a service, but that's risky because the key is exposed in a public-facing file, and that's not really a recommended strategy. Instead, we'll use something called the token auth strategy, in which we'll use a server to hand out tokens to the clients. So for that, we'll add another route called /auth, the same way as here. So app.get/auth, request response, and we have the callback. Actually, you know what? There's an easier way to do this. Let's go to the Ably homepage again. And from the developers drop down, we can go to tutorials and search for token. So there is a tutorial called implementing token authentication. How convenient. So if we open that up, we can skip to the part which says respond to authentication requests and scroll down. That's exactly what we need. So copy that out. And back in our code editor, let's just paste that, remove all the unnecessary stuff. The method is repeated as well. Just remove that. And this is called REST, but we're using the Realtime library, so let's just replace it with that. So in the token parameters, we'll actually send a client ID to every player that attaches. This would be a unique way to identify each of the players. So to create that unique ID, let's create a function called unique ID and return some sort of a random ID. So ID dash math.random. Maybe convert it to string and take some characters out of that. Let's go back to the auth endpoint and call this function unique ID. Now, before we move forward, let's understand a quick concept called channels. Now, in a real time application, there's lots of moving data all around, and it's not necessary that all the participants in that application are receiving or publishing all that data. So, there is a concept in real time world called channels where you distribute different sets of data into logical sets. Like in this example, as you can see, there's a location channel which carries location data and a job updates channel which carries only that data, and only the participants to whom that data is relevant will be a publisher or subscriber or both on that channel. For our game, we'll have a game channel which will be used by the server to send the collated game state updates to all the players and also track players joining and leaving the game. And we'll have one channel per player using which they can send their input, which is, the space key presses. We'll have one more channel called the high score channel. I'll explain later what this will be used for. Back in our code editor, we'll start with checking if our server has connected to Ably. So realtime.connection.once. We'll set up a callback for the connected state. We'll start by setting up the game channel. We can get a channel instance using realtime.channels.get, but we haven't yet specified what we want the name of the channel to be. So let's scroll back up and say const game channel name equals Flappy game. And let's also declare the other variable game channel. So realtime.channels.get game channel name. Alright, so let's take a quick detour to understand another concept called presence. So presence tells you the online status, or essentially gives you an update when a new client gets connected or gets disconnected from the application. We'll use this to see when new players join or leave or even die in this Flappy Bird game. Okay, so back in the code editor, we'll say game channel.presence and we want to listen or subscribe to the event enter. And whenever some message occurs, let's specify a variable called bird count, initialize it to 0. And when someone enters, we want to increase that bird count by 1 and check if it's the first bird to enter, which means it's time to start the game. So we'll declare a variable called game ticker and say set interval, call another method called start game tick, and do this every 100 milliseconds. We'll declare another variable called is game ticker on and set it initially to false. We'll just use this to make sure in no case the game ticker is being called multiple times. Right, so let's define that method start game tick. Let's declare another variable called game state object and one more called birds, and this will hold all the birds information, basically the collated state of all the players. Two more variables, high score and high score nickname. We'll use these later, but just initialize these with 0 and anonymous panda for now. So back in the start game tick, we can build the game state object by adding birds as birds, high score as high score, and high score nickname as the variable high score nickname. We'll update these later, but this is what we want to publish in every new update to all the players. So let's say game channel dot publish an event name called game state and just publish this game state object. Okay, next, back in our presence enter callback, we'll actually enter this bird's information into the bird's associative array that we built, and we'll identify each entry by the unique client ID of each bird, and that'll have ID as message.clientID. Bottom as will make it equal to the bottom positions that we specified on the client side, which is 350. Initially is dead would be false. We'll have a nickname key, message.data.nickname, and one more key called score, which we'll initialize with 0 when someone enters. And for each of these players that enter, we need to subscribe to player input. So we'll call a method, pass it the message.clientID, and we'll define it outside of this function, which takes the parameter ID. We'll not define it just yet. Now, just like we subscribe to the enter events on presence, we'll also subscribe to leave. So game channel.presence to subscribe leave event, and in the callback, we'll say if, we'll first see if that bird exists at all. If birds of message.clientID is not equal to undefined, then bird count minus minus. And then we'll set the isDead key of that bird to true. We'll also delete that entry from the associative array. But let's actually put that inside a timeout function. I'll tell you why I do this in just a second. After that, we'll check if the bird count has reduced less than 1. If so, the game ticker will make that false because there are no birds playing and we don't want to keep publishing messages unnecessarily. And we'll also stop the game ticker by clearing the interval. Now let's go back and finish the subscribe to player input method. Let's scroll back up and declare a variable called bird channels. We'll use this to store all the bird channels. So in the subscribe to player input method, we'll say bird channels of ID equals realtime.channels.get bird dash position dash, and we'll identify that channel uniquely using the ID of the bird. And we'll say bird channel of ID.subscribe to the event position, POS. And in the callback, whenever there is a message on that channel, we'll say if that bird still exists, we'll say birds id.bottom equals message.data.bottom. Birds id.nickname equals message.data.nickname, and birds id.score equals message.data.score. Because we are getting each bird score here, we can also check if it has crossed the high scores. So we'll add a small check. If message.data.score is greater than high score is message.data.score, and high score nickname is that bird's nickname, which is message.data.nickname. Okay, so that's most part of our server.js. Everything looks good. Looks like there's a typo, set time out. Now everything looks good. Let's make some changes to app.js. I'll put the two files side by side, the server and app.js, so we can reference all the things. Now on the client side, unlike server.js, we can simply start using the Ably service by including it as a CDN in the HTML. So let's go back to the documentation, copy that, and paste it in the HTML. Okay, let's instantiate the Ably library. Const realtime equals new ably.realtime. And this time, instead of using the API key, we'll use an auth URL because we set up the auth server. Now, /auth is the route of the auth server. We can do this because the server is in the same place as the app. Otherwise, you'll need to include the complete URL of your authentication server here. Okay, so let's start with connecting to Ably. Let's say realtime.connection.once. When the state is connected in the callback, we'll start with getting the client ID. So let's declare a variable. My client ID equals realtime.auth.client ID. And let's set up a publish channel. My publish channel, let's declare that. My publish channel equals realtime.channels.get bird position, if I'm not wrong. Let's check that in the server. Bird dash position dash with my client ID. Then we need the game channel. So let's declare that. Game channel equals realtime.channels.get. This will attach to the channel. We need a channel name. We haven't declared that. If you see in the server, it is Flappy-game. So let's add this here. Get that variable and paste it in here. Cool. And we can move all of the on-click functionality, which actually starts the game. The on-click listener inside of this connected method. So we make sure it is being done only after the connection to Ably is established. Now we need to make this client enter the present set. So we say gamechannel.presence.enter. And because the server is expecting a nickname, among other things, we will add that as a key value object. Nickname, that would be my nickname. As you can see, this is where it is using the nickname in the server, which we send through the message, the presence message. Okay, so next we declare two methods. Next we call two methods, send position updates to send my position to the server, so I can show birds belonging to other players in my screen. So let's go ahead and define the send positions update method. In there, we'll set up a timer called publish timer and set an interval. On my publish channel, which we set up earlier, we'll publish an event. Let's see in the server, it's expecting an event called POS. So we'll publish that and we'll publish bottom, which would be my bird's current bottom, nickname, which would be my nickname, and also score, which would be in the variable my score. If the game is over, we'll basically stop publishing. So clear interval publish timer, and also will detach from this channel my publish. We're running this interval every 100 milliseconds. So let's implement the showbirds method next. We'll subscribe to the game channel to the event name game state. So game channel.subscribe game state, and in the callback, we basically want to iterate through all the birds in the list, and for any bird that is not my own avatar, so item is not equal to my client ID, we say new left. Actually, in the birds object, left isn't there. So new bottom equals message.data.birds of item.bottom. Then we have is dead similarly. Let's scroll back to the top and declare a variable, all birds, where we'll store all the birds. So we'll check for the condition if that bird already exists with me locally and it is not dead. Then we'll add the target bottom, not the actual bottom, but I'll tell you in a bit why this is. So the target bottom equals new bottom, and is dead is dead from the message that we got. Similarly, nickname is the nickname from the message. And finally, score is also the score from the data, from the message that we got. If this is not true, we'll go for an if condition and say if this item exists with me locally, but if this bird is dead. So this is why we had actually waited for 500 milliseconds, so we get such an update where a particular bird is declared dead before that is deleted on the server's end. So that's what we check here. And let's actually add a reference to the sky element where we can add the birds. So if you see the HTML, it is identified by the class sky. So let's do that. And from the sky, we basically, if a bird is dead, we remove the element of that bird. Now this might be a bit confusing because we haven't really specified it yet. Don't worry, we'll know about that soon. Then because it's dead, we'll also delete it from our local variable. Now in the last and final case, it basically means that the bird doesn't exist, which means we need to create a new object for this in our local associative array. So after checking if the game is not over, we'll add an empty object for this bird, and we'll make it a div and set it in the EL property of the object. We'll assign it the class other bird. As you can see in the CSS, other bird is already defined. It essentially has z index -1 and a bit of transparency. So it appears to be in parallax or behind as a layer from all the other elements, and also it's a bit transparent so you don't get confused with your own avatar. Let's append this new bird to the sky. So after that's done, we also add the style bottom equals whatever the message bottom is, which is new bottom. We also set the is dead entry of this new bird, same as the message. Similarly, the nickname and the score, like we did in all the other cases. Now, if it is my client ID, which means I've got an update for my own bird, So I'll basically just add that entry into my local array directly. We also have the high score above, and because this is a place we're getting all the scores of the birds, each time we can just check to see if the score is greater than high score. If so, replace the high score with that and replace the high score nickname with that player's nickname. We'll also change the label of the top score by setting this high score and high score nickname so it stays there. So if you remember, back in the generate obstacles, we had target bottom. Let's go to the start game and set this up. For item in all birds, basically iterating through all the birds, if it has a target bottom, then basically I want to move from the current position of that bird to the target bottom, but by increments of half that distance. So what we're doing here is that it basically makes it look like a smooth movement rather than making it look jittery due to network updates. Next, we need to move the generate obstacles method on the server side so all the players have obstacles coming up in sync. So in the server, let's say obstacle timer equals 0. So we'll use this to generate obstacles every 3 seconds. If obstacle timer equals 0 or 3000, then basically send this object inside there and set it to 0. So basically reset it to 0. And then we add two other key value pairs called launch obstacle, which will be true in this case, and the random height, which we'll take from the client side, which is math.random times 60. If it is not the case, then for all the other times when we don't want the obstacle to be launched, we basically set this launch obstacle to false. We'll then increment this obstacle timer by 100 in every cycle. So if I run this server now and open up two clients, we can check this out. The bird seems to be on the far left, and that's not what we expected. So it seems like we do need to add the left element, left value, when we create the bird object. So we'll say left 220 and update it on the client side as well. Let new left message.data birds item.left. And we'll take that. We'll go to the first condition and all birds item. We don't need a target here. We just need left equals new left. The left is always going to be the same. And also we append it with pixels. And in the next condition, we say all birds item.el.style.left equals new left plus px. Also, it looks like I have a typo. I've written other birds instead of all birds, so I'm just going to fix that up. And in the game over method, we basically need to make the bird leave the game. So we go there and say game channel dot presence dot leave, and we'll also detach from this channel then, game channel dot detach. We'll also close the connection with Ably, realtime dot connection dot close. So we don't actually have a live leaderboard yet, so let's implement that next. We'll call it sort leaderboard because we'll also sort the scores. So in the score label, we'll set our score here. We'll have a variable called list items and we'll set it to an empty string. Another called leaderboard, and this will be a new array we create. Now we'll loop through all the birds that we have in the all birds array, and then we'll push the nickname and the score bits to the leaderboard array that we just created. And we'll use a JavaScript sort method to sort it in descending order. Now, for each of the items in that leaderboard array, We'll basically create a piece of HTML where we'll specify that as a list item with the necessary CSS classes. So we'll have the bird score and the bird nickname. And we'll append it to the list item that we created before. Now back in the move obstacle method where we were updating the score label, we'll remove that and instead call the sort leaderboard method from there. We'll actually call it with a delay of 250 milliseconds because we want the my score thing to go to the server and then we want that update to come back from the server, which is when we want to sort. We'll also call the sort leaderboard method just before the game is over, just to force the sorting of leaderboard one last time before the game is quit. So we just have a couple of things left to implement in this project. Because we are not connected to a database at all, any top score that we save on our server will be reset when we restart our server. So instead of that, we can make use of the functionality in Ably called Rewind, which lets you get a previously published message at the time of attachment if you connect within a particular deadline of that message being published, usually up to 72 hours. So let's declare a variable called topscore channel and we'll get that channel, subscribe to the score event on that channel. And in the callback, we'll essentially assign the high score and high score nickname from whatever comes from that channel. And here we'll also unsubscribe from this channel because we don't no longer need it. Whenever we have a new high score, we'll also publish to this channel so it has the latest info and we keep publishing whenever things are changing. Let's do this on the client side as well. Declare top score channel name, which would be Flappy top score. If we come back down to the connected method, we can say top score channel equals realtime.channel.get top score channel name. And this is where we'll specify rewind as a parameter. So params rewind 1 because we need only one message to be rewound. And we'll subscribe to messages on that channel. Similar to server, we'll update high score and high score nickname. We'll also update the label with this latest info, then we'll unsubscribe from that channel. I was being very stupid and I never actually added the rewind parameter on the server side. So adding that. Okay, so we've implemented all we need. Let's try out the game one more time. I'll attempt to be both players side by side. And that's a bad attempt. I'm just dead. But looks like everything we want is working as expected. Cool, I'll test this out further and any updates or bug fixes that I make will be available on the GitHub project. Hope you enjoyed building this multiplayer game of Flappy Bird with me. I've linked to all the resources and references that I mentioned throughout the video in the description below, so make sure to check that out. I previously built another multiplayer game of Space Invaders in a similar way, and based on that, I released a multiplayer games framework based on the client-server strategy. You can use that as a base to build your own multiplayer games. So feel free to remix any of those resources and at me and Ably on Twitter with your games in real-time apps so we all can see and share your projects. Finally, don't forget to catch the QA session on Eddie's channel. See you then!